16, hydrogen is 1, 16 plus 2, 18 grams. So this is how we determine what we call the molar mass for each of the compound there. As long as you know the formula, all you need to do is a simple addition. You add all the atomic masses that you can find in the periodic table for each of the elements. You add them together, you come up with the molar mass there. Okay? So in terms of the calculation involving elements there, we need you to be able to convert mass into moles, and then moles into the number of atoms there. Now what's the conversion factor? Going from mass to moles, the conversion factor is the atomic mass that you find in the periodic table. And that's why we always give you a periodic table when you take exams there. We don't need you to memorize. I would prefer you to memorize, but we don't need you to memorize everything in the periodic table. Okay? We'll give you the conversion factor. Going from mass to moles, atomic mass is the conversion factor. What's the conversion factor going from moles to number of atoms? That Italian scientist, we gave you the name, Avogadro's number. So each mole will have 6.02 times 10 to the 23, that many number of particles there. If you have 3 moles, 3 times 6.02 times 10 to the 23. So when you are doing calculation involving elements there, be able to convert mass to moles, moles to number of particles there, or the other way around. Given the number of particles there, you can figure out how many moles there, because each mole has the same number of particles, no matter what kind of substance you're talking about. And using the periodic table, you can convert moles into mass. So each going from left to right to left, you need to be able to do these kind of calculations. Okay. So now if you think about it, the mole is just like, the Avogadro's number is just like a dozen to the baker. A dozen is 12. A mole is 6.02 times 10 to the 23. That's a huge dozen. A very large number. That's our conversion factor. If I ask you to give me 3 dozens of chocolate chip cookies, you count out 36 of them. Okay, so that's 3 dozen there. And if I ask you to give me 3 moles of iron, you don't count the atoms out. That's going to take forever. Rather, you measure the mass out. So for the calculation involving the elements there, we need you to be able to do the conversions. No, there's nothing new here. Dimensional analysis. All you need to do is to identify the conversion factor, plug it in, cancel out the unit you don't want, get up to the unit you do want. Okay? So what we need you to be able to do is, for moles to mass conversion, the atomic mass, you put the mole on the bottom in the denominator and grams on top. This number is something that you can get from the periodic table. Remember, we don't need you to memorize the periodic table, so this information is always given there. Okay. And then if you have the number of moles multiplied by this conversion factor, mole cancels out, will give you grams. So that's how you convert moles to grams. Okay. You need the atomic mass there. Now if we have mass, say 35 grams of iron, we need you to convert it into moles. It's the same conversion factor, but you flipped it. Because you have grams now, you want it to be in moles. So each mole is equivalent to whatever number of grams for that particular element there. Okay. Gram and gram cancels out, leave you with moles. So molar mass is the conversion factor from going from moles to grams. The inverse of the molar mass would be the conversion factor going from grams to moles. Again, there is nothing new here. We are talking about dimensional analysis. The information given to you in the periodic table is our conversion factor. It just depends on which direction we are doing conversion. And plug it in, cancel out the unit you don't want, and leave you with the unit you want. So it's pretty easy. Okay? So for the Chemist Try, we're still in Chemist Try class there, so let's take a look at the problem there. How many atoms of aluminum are in a piece of foil with a volume of 2.00 cubic centimeter? Given the density, aluminum is 2.702 gram per cubic centimeter. Now remember that critical thinking slide we're talking about. We're always going to ask you questions a little bit more complicated than who's buried in Grant's tomb. So in this case, we're asking you how many atoms of aluminum in a piece of aluminum with a volume of 2.000 cubic centimeter, given the density? Well, you have to know the mass. Okay, so in this case, we got to figure out the mass, and the density is given, volume is given. So how do we define density? Okay, so volume is given 2.00 cubic centimeter, and density is given 2.70 gram per cubic centimeter. Mass is our x there. So you multiply the volume by density, cubic centimeter cancels out. Okay, so we can figure out the mass. Now, once we get the mass, we can figure out the number of moles. Once we figure out the number of moles, each dozen has 12, each mole has 6.02 times 10 to the 23. So when we do the calculations there, we need to first find the mass there, and this is the equation that we use to find the mass. Okay, so in this case, after finding the mass there, we can figure out the volume, the moles. So once we figure out the moles, we find the number of atoms there. Okay, so in this case, if you multiply these two numbers together, the unit for this number is gram per cubic centimeter. If you multiply by 2.00 cubic centimeter cancels out. So in this case, x equals to 5.40 grams. So that's the mass of the aluminum. Okay. Now if you look at the periodic table, each mole of aluminum weighs 27 grams, roughly 26.98, somewhere in that neighborhood. Okay. So if you have 5.40 gram of aluminum, each mole, let's use 27. Now this information, you don't have to memorize it. This information is given in the periodic table. Okay? So gram and gram cancels out. 5.40 divided by 27. That's the number of moles. The question is not asking the number of moles. The question is asking you how many atoms do we have? Well, each mole, 6.02 times 10 to the 23. That many atoms there. A mole cancels out. So what we have done so far in this example, we're just doing dimensional analysis. Identifying the correct conversion factor. This correct conversion factor comes from the periodic table. This is the chemist dozen, just like the dozen for the baker, 12. A dozen for the chemist, 1 mole equals to 6.02 times 10 to the 23. And every step of the way, you can see the gram cancels out, mole cancels out, leaving you with the number of particles of the atom there. And if you do the calculations correctly, these are the answers we're going to get. The number of atoms is 1.21, 3 sig big times 10 to the 23. That many number of aluminum atoms in this particular piece of aluminum foil. So that's how we do the calculation, converting mass into the number of particles. Each step of the way, we're trying to help you to identify the correct conversion factor. Once you have the conversion factor identified correctly, then you get the answer. Punching them, the rest of it is easy. You just punch the number in the calculator and you can do the calculation. Okay. And another example here. So an experiment requires 5.5 grams of iron in the powder form. How many moles of iron are needed, and how many atoms of iron in the sample that is required? Well,